Welcome to Module 5, where we'll talk about virtualization using Hyper-V. Hyper-V is going to be a very popular product that has been competing with VMware for many years, and they roughly have about the same amount of market share as each other out in production. Now, this doesn't include VMware Player Workstation. That's because that's typically not a production type of product, but ESXi out in VMware definitely is. And one of the reasons why we've seen Hyper-V expand their market share over the years is when you buy a Windows server, you automatically get two Windows operating systems included for virtual machines. So that's roughly a couple of $1,000s worth of value. But if you go to VMware and you buy a Windows server, you don't get those two virtual machines. So in this module, we're going to talk about Hyper-V features, the server role, Hyper-V manager, hosts, and migration to Azure. The way virtualization works is you've got a host computer, and then you've got virtual machines that can sit on top of that host computer. And each virtual machine operates independently from each other. So you can't even tell if you're connecting to it remotely that a server is virtual or physical. Now you have to install the Hyper-V role, which installs the hypervisor onto your computer. And so basically that means that you're going to need to make sure you turn on virtualization in your BIOS or UEFI. Hyper-V comes included with all versions of Windows Server that include the GUI, which would include Standard and Data Center. It does not get included, however, with Essentials. But Essentials has a lot of other great features for small businesses. And you can use various different guest operating systems. These are virtual machines that run on top of your physical host. And that could include all different versions of Windows. Then you have different versions of Linux as well. Now, you just see a short list of Linux versions. You can actually do a lot more than that. You can be fairly simple in your scenario that you have with virtual machines, or you can be very complex. So a simple setup would be basically you just put some virtual machines on a host and that's it. But you could also add in clustering. So you add in multiple server nodes, shared storage, and you could cluster those together. You could replicate the virtual machines to other locations. You could definitely get very fancy with it. You could also add in virtual desktops. So you could take your Windows 10 or 11 client, and then you can make a lot of them virtually, and then marry that into the remote desktop services, and you've got virtual desktop infrastructure. And that allows users to connect to their same virtual machine every time they log in. So they always get the same view that they had when they logged out previously. There's lots of different features when you set up Hyper-V on a Windows server, and you can also set up Hyper-V on a Windows client, but you don't get the same amount of different features that go along with it. So on a server, you get management connectivity. That's pretty standard on both client and server. Portability, you can basically move your virtual machines from one location to another. Disaster recovery and backup. When you run the Windows Server backup program, you can automatically back up all the virtual machines on that server. There's lots of great security features that come with Windows Server 2019 that weren't available in previous versions, and you can optimize to make sure that you're running the servers in a way that doesn't negatively affect the host. One of the nice add-ons to Windows Server Hyper-V Manager is the ability to add alternate credentials. So that would be multi-factor authentication if you wanted to do that when you go to log in. And we have different ways that we can manage these virtual machines. You can manage them using PowerShell, PowerShell Direct, as well as Windows Admin Center, which is the web version of management. There are some best practices recommended by Microsoft when deploying Hyper-V, and that is the provision the host with adequate hardware. You definitely don't want to slow down your host by over-provisioning virtual machines with too much RAM, too many CPUs, too much hard drive space, that kind of thing. Deploying virtual machines on separate physical disks on the host, that's just unrealistic, although it does improve the quality or the speed of your virtual machine. It's just not like if you have 20 virtual machines, are you really going to have 20 hard disks to do that? I doubt that. So most of the time, you just need to put in a RAID controller, high amounts of storage, use SSD or NVMe if you want high speed, or even SCSI drives if you'd like as well. You can manage Hyper-V remotely using various tools. There's a really good best practices analyzer as well that you can run from Server Manager, and it will tell you whether or not your Hyper-V setup has the best physical and best security setup it could have, and it'll give you suggestions on how to fix that. You can use Generation 2 VMs, which are more secure. It allows you to use Secure Boot and other built-in security features as well. Overview of nested virtualization is basically something that allows you to put virtual machines inside a virtual machine. So if you have Hyper-V running on your server and you've created a virtual machine, you can put Hyper-V on that virtual server and add another nested one into there. You may get to the point where you don't have enough physical infrastructure to handle all your virtual machines, or you want to replicate your virtual machines off to the cloud. Well, you can do that using Azure Migrate Assist. So you can move those virtual machines over to Microsoft Azure so they run there if you'd like, and then you'd no longer need the physical host to run it. However, they make it sound like it's less expensive, but it turns out it's a lot more expensive to do it that way. It's much cheaper to host on a physical host than it is on a virtual one using Microsoft Azure. Let's take a look at configuring virtual machines. There are a lot of different settings that we can change in the Hyper-V virtual machines and the Hyper-V manager itself. You may end up having multiple Hyper-V host machines, and you can either cluster those together or set them up with replication if you'd like, or just have them operate as separate physical hosts if you want to do it that way. VM configuration identifies the compatibility of virtual machine components with the Hyper-V installed on the machine. So if you don't have the right components that work with Hyper-V, then you'll have a problem deploying it, or you may just not have all the features involved as well. There's configuration, runtime state, virtual hard disks. That's where the virtual machines themselves are kept. And the checkpoints are interesting. What you do there is if you end up running Windows updates, you want to run a checkpoint just before the updates. And then if you have a problem with your update that causes a problem with the server, you just use your checkpoint to go back in time. Once everything is configured the way you want it and it all works the way you want it after that update or whatever change you're making, then you can go ahead and delete the checkpoint. Otherwise, it ends up causing a lot of hard drive space issues because it ends up creating a separate file from your original virtual machine, and it branches off from there. So checkpoints are great for short periods of time, just for the type of experience I was telling you, but they're not good to leave there long term. Hyper-V creates a VHD or a VHDX file, just depends on which one you pick, when you create your virtual machine. And you can use any free space on your Hyper-V host for that virtual machine. It's best to use it on a separate partition than the partition that Windows is using to run the operating system, just because it runs faster if you do it that way. But you can certainly use any storage available that you'd like. If you're connecting to a storage area network device, which is just a box of hard drives, you want to make sure that you have the fastest storage possible. And it's a good idea to have redundant storage, such as with RAID 5 or RAID 6. So in case a drive fails, then you'll be able to continue running. High performance storage is always a good idea, using faster hard drives rather than traditional 7200 RPM spindle type drives. And then you want to have adequate growth space. You don't know how big this virtual machine may need to be. So you want to make sure that you have enough space as well as space for additional virtual machines when necessary. So as I mentioned before, you do create either a VHD or a VHDX format when you create your virtual machine. There's really not a lot of difference between the two. The VHDX is the newer format of the two and typically associated with Generation 2 types of virtual machines, whereas VHD is generally thought of with Generation 1 type virtual machines, which are 2008 and older. However, it's still possible to make a VHD file even on a Windows 2019 server. Hyper-V consists of a virtual network adapter and a network switch when it comes to networking. So when you create your virtual machine, and well, actually when you first install Hyper-V, it's going to ask you which network card is going to be your virtual switch. So then you pick which network card you'd like. It could be any network adapter you like, but of course the faster the better. And then when you create your virtual machine, it creates a network adapter or network interface card that connects to that virtual switch. So really you're bypassing the need for a lot of hardware. It's all virtual within the operating system itself. Hyper-V supports a lot of older networking adapters, such as the old Intel 21140 PCI Fast Ethernet. That's the 100 megabit, but it also supports a lot faster ones as well, such as gigabit speed adapters. Moving beyond virtual machines are Windows containers. Now, some people are getting rid of their virtual machines altogether and replacing them with containers. So a container is an application that you can move around. So it's got everything it needs within the folder where the application lives. So if you need to move, say, a container that's acting as a web server, instead of the usual way where you've got a lot of hooks into the Windows folder, the DLL files, the INF files, all the different files that are all over the place, it's pretty much impossible just to move that application. But if you set it up as a container, it's all self-contained, and you can just pick it up, move it to another place, and start it right up again. And you can even set it up using various different management tools like Kubernetes to automatically move if it realizes that a server that it's running on is having problems. So it'll move itself to another container server. So containers versus virtual machines, there are advantages and disadvantages to both. Virtual machines and containers, they both use virtualization technology. However, virtual machines, the traditional type, are very heavy. They're kind of spread out, being used through the application of Hyper-V, which is being used in various different places. And they're both used to provide isolated and portable computing environments for various different applications and services. However, Hyper-V, traditional Hyper-V, is really designed for an entire operating system where you reinstall those applications and those services on it. Whereas containers, you can install them once on your container server, and you just have to download the containerization application on your Windows server through PowerShell. And then everything that it needs is all in this one self-contained location, so it can be moved very easily. So there's some isolation modes that we want to talk about. Process isolation. That's the traditional isolation for Windows containers. So it includes the process isolation that enables multiple container instances to run on the same host all at the same time. So when you run in this mode, containers share the same kernel with each other as well as the host operating system. So obviously that could cause a problem if they share the same kernel. If the kernel fails for some reason, then it's going to cause all the containers to fail as well. Or if there's a compatibility issue with the container application, but it's not a problem for the host operating system, then you will also have a problem. However, you won't have a problem with the host itself. So each container features its own user mode, and that allows Windows and app processes to run isolated from each other. Although they're isolated from each other, which is great, they still do share that kernel. The other option is Hyper-V isolation. Now, this should not be confused with a traditional Hyper-V virtual machine. With Hyper-V isolation, the containers run inside their own highly optimized virtual machines. They're very tiny, very lightweight, easily moved. So the advantage of this mode is that the container gets its own kernel. So the original container, they share a kernel. This one gets its own. So that adds an additional layer of usefulness as far as if you have a problem with the host kernel, it's not going to be affected here. So that additional layer of hardware isolation can give you a big advantage over the original container that was created for Linux servers. Now, when you do decide to use containerization on a Windows server, you do end up loading a virtual Linux server, which does all of the management of your containers, whether they be the Hyper-V isolation or the process isolation. And you can't really get rid of it. You can use a Linux server all by itself if you like, if you don't want to use it through Windows, and then you can manage it using one of many different types of tools. Kubernetes, by the way, is something you can use to manage both the Windows containers and the Linux containers. It was originally developed by Google, and then Google decided to open source it, give it away to everybody. And so that's why you can now use it in Windows as well. Windows uses what's called Docker to create your containers. So when you create your container using Docker, you specify which isolation mode, process or virtualization, and then you go ahead and choose your command that runs and creates your container. So you can see Docker run, and then you have isolation for the mode, process, and then the location of where it's located, and then you hit enter. Docker is going to be a collection of open source tools, so there's no additional charge to run this on your Windows server. Docker runs on what's called the Docker engine, and it's a lightweight runtime environment that runs Linux, Mac operating systems, as well as Windows-based operating systems. To install Docker on a Windows server, you need to open up PowerShell and then type in docker-microsoft package management, and then it goes ahead and downloads the Docker application onto your server along with that Linux piece, and then it configures everything you need to start using containerization. It even comes with some test applications that you can use, such as a web server. You can also run Docker on Windows 10 and 11 Pro and Enterprise on those client computers, and you can download what's called the Docker Desktop. Now, I wouldn't use this for production, but it's very good for practice, and then you can use the production version on the Windows server. You can manage containers using Windows Admin Center, which is that web-based graphical user interface. You can install it on any computer that you'd like and then connect to your Windows server remotely, and then you can manage your containers that way. There are something called containers extensions. So Windows Admin Center, when you go into Windows Admin Center, there's an option to add an extension. And basically all this is the tool that manages containers. So by default, you're going to find a certain amount of extensions already installed, such as the event viewer in Windows Admin Center. That allows you to view the events of any Windows server or client that you have connected to Windows Admin Center. And there's other ones that are default as well, such as services, add roles and features, things like that. But there are some things that are not included, and the containers extension is one of them. But you can easily go into the containers settings area and you can download the extension, and then you can connect to the server that's running containers and start managing them. Windows Container Orchestration. So these containers provide a lot of benefits for applications and agile delivery environments. So what that means is that you can move your containers from one location to another. And they don't use a lot of resources like some full-blown, say, web servers, for instance. But because they're lighter weight, they also don't have the same capabilities as a full-blown Internet Information Services web server would have. But it has most of what you need in most cases, especially for a simple site. When you want to automate processes within a containerized environment, then you need to use what's called an orchestrator. An orchestrator, all it is just a way to automate processes, and it manages a large number of containers. It does all this good stuff for you. So your orchestrator tasks can include, but they can also have more things as well. You have scheduling, affinity, which basically allows you to pick which processors you're going to use, monitoring, failover, scaling, networking, and others. And there's several container orchestration tools that you can use. As I mentioned before, Kubernetes is one of those. You can manage all of your containers using Kubernetes, and you can set up orchestration where you can set up automated tasks that will happen on many different containers all at once. Docker Swarm is another option, Docker's own fully integrated container orchestration tool. Now, if you're going to use an orchestration tool where you're going to learn this, so when you get a job, you'll have the skills needed for a production environment, I recommend Kubernetes. And that's because that's going to be the majority of people that will be using it. It works on both Linux and Windows and Macintosh. So it's really a good idea. Docker Swarm, I'm not saying it's a bad orchestration tool. It's just not being used as much as Kubernetes. Then you have the Apache Mesos. Never used this one before, so it's not that I don't recommend it. It's just if you want to use the one that everybody's using so you can be more employable, then I would focus on Kubernetes. As you see here, Kubernetes is based upon common cluster technology. So common cluster technology basically allows you to have failover and highly available resources, in this case, containers. And so it's got the centralized software for the master control, and it's responsible for scheduling and controlling all the tasks within the cluster. You have to have at least one master controller, and it runs a lot of different services that run this orchestration or this automation. And currently only Linux is supported as the host operating system, which is why you're going to have a Linux portion on your server. So to set up Kubernetes to work in your location, you've got to create the master, configure the networking, join the worker nodes, that's just basically the servers that are running the containers, and then manage the Kubernetes resources. In this chapter, we learned about Hyper-V, we learned about containers, and orchestration for managing those containers. And that will do it for Module 5.